This is a stock chart. From late February this year to now, it's up more than 150%. It's not NVIDIA, it's not TSMC. Most people have never even heard of it. The company is called AXT, ticker AXTI, a small company that makes semiconductor substrates. But its latest earnings report tells a story about a hidden bottleneck inside the AI industry that almost no one is talking about. AXT makes something called indium phosphide substrates. That probably sounds unfamiliar, but its role is critical. It's the starting material for manufacturing high-speed laser chips. Why does that matter? Because silicon, the backbone of the entire chip industry, has a fundamental physical limitation. Silicon is very bad at emitting light. And in AI server infrastructure, the future of data transmission is optical. Light. Faster, cooler, more efficient. And right now, that light has to come from somewhere. That somewhere is indium phosphide. To understand this stock, you need to grasp one simple physics concept. Almost every chip in the world is made from silicon, because silicon is cheap and easy to manufacture at scale. But silicon has a natural flaw. It barely emits light. For most of computing history, that wasn't a problem. Chips just used electrical signals through copper wires, and that was fast enough. But the AI era is different. Think about a traditional data center like an office building. Servers on the same floor could pass data to each other, like handing someone a note across the room. Copper wire was fine. But today's AI clusters, something like NVIDIA's GB200, have tens of thousands of servers that need to communicate across massive distances. Copper wires can't keep up. They create heat, they create congestion, and they hit a speed ceiling. So the industry is moving to light. Here's the analogy. In the old world, you were passing notes inside one building. In the new world, you need to move data across an entire city at the speed of light. To do that, you need to build a high-speed rail line that runs on light. And indium phosphide? That's the locomotive. It's the laser light source. Without it, the entire optical infrastructure, silicon photonics, co-packaged optics, can't even start moving. What AXT does is take indium phosphide and turn it into wafer substrates, flat disks of material that get sold to laser chip manufacturers downstream. The entire AI optical interconnect supply chain starts here. Let's look at where AXT was just a year ago. Full year 2025 revenue, $88.3 million. Gross margin, 12.7%. Net loss for the year, over $21 million. In Q4, the company publicly cut its revenue guidance. The reason was specific. The number of indium phosphide export licenses issued by China's Ministry of Commerce came in lower than expected. AXT's primary manufacturing is in China. The problem is that indium, the key raw material inside indium phosphide, is on China's export control list. Even when AXT had production capacity ready, every single shipment to overseas customers required individual approval from the Chinese government. But the orders didn't disappear. They just got stuck at the approval gate. And while they waited, AXT's backlog of unfulfilled indium phosphide orders kept climbing. Then, in 2026, things started to unlock. For nearly a year, that record-breaking backlog sat frozen behind the export approval process. AXT's own filings said it plainly. Demand was strong, but product couldn't ship. Then, at the most recent earnings call, the CEO confirmed that export licenses were coming through, and the company announced plans to double its indium phosphide production capacity within the year. This artery of AI optical supply, blocked by geopolitics for almost 12 months, is being reopened. The numbers reflect it. Q1 2026 revenue came in at $26.9 million, up 39% year over year, up 7% from the prior quarter. But the more important number is gross margin, from negative 6.1% a year ago to positive 29.9% in a single year. Indium phosphide now accounts for more than half of total revenue, and the NP backlog hit a record, $100 million. The company is guiding Q2 2026 revenue to at least $34 million, which would be the highest single quarter in company history, and expects to turn profitable for the first time. In under 12 months, they've gone from a net loss of over $21 million to the edge of profitability. That's the turn. So how does Wall Street see this? The answer is not unanimously. Wedbush has a $93 price target with a buy rating. Their thesis is that the speed of gross margin recovery exceeded expectations, and they see more upside in the second half of the year. Northland is even more optimistic. $90 target, also buy, pointing to accelerating AI-driven demand for optical interconnects. But B. Riley is much more cautious. $72 to $73 target with a hold. Needham is also at hold with a $79 target. Here's what's worth noting. The average price target across all 5 analysts is actually below where the stock is trading right now. In other words, the stock has run faster than analysts have been willing to upgrade their targets. Whether that means the market is pricing in more than the fundamentals can support, or whether the fundamentals are genuinely strong enough to justify the move. That's exactly the debate happening right now, and there's no consensus answer. The shortage gave AXT something unusual: pricing power. When only a handful of suppliers could actually obtain export licenses, customers had very few alternatives. Negotiating leverage sat with AXT. So what happens when the shortage fully resolves and alternative supply sources mature? One scenario: customers, motivated by supply chain diversification, actively seek second and third suppliers. Over time, that could erode the scarcity premium AXT benefited from. But here's what's actually happening on the ground right now that complicates that picture. While AXT's substrates were stuck in the approval queue, the world's largest tech companies didn't stop and wait. They started routing around the problem, sourcing non-China substrates and working directly with Asian epitaxial wafer manufacturers, specifically to ensure that supply chains for 1.6T high-speed optical modules wouldn't be held hostage by a single choke point again. That behavior tells us 2 things. First, the urgency of AI optical demand is real enough that major customers won't accept supply risk. Second, and this is the less obvious read, this shift toward multi-sourcing isn't shrinking the indium phosphide market. It may be expanding it. When supply is no longer the constraint, downstream manufacturers feel safe enough to scale up investment and commit to large orders. The total size of the NP market could get significantly larger as a result. 2 forces, pulling in opposite directions, one that weakens any single company's pricing power, and one that grows the overall market. Which one dominates the next chapter of this story is still an open question. AXT's story is really about something that gets overlooked in most AI infrastructure conversations: materials. The substrate layer, the supply chain that starts before the chip. The shortage easing is a good thing, but what comes after a good thing, that's worth watching carefully, not rushing to a conclusion on.